Okay, so you're done with your maths exam?
Yes, I am.
Okay, fine. So please like be regular, otherwise it gets difficult for me also as well, and you will also miss some important concepts in between. Okay, so today I'm going to start with a new chapter that is called pair of linear equations in two variables, right?
Yeah.
Okay. Okay, so now I'll start with the term. First of all, what is an equation? Okay, let us try to understand. Very basic. So what is an equation? Now, what is the difference between an equation and a polynomial? So the last chapter you did was called a polynomial, right? So any expression, whether it is quadratic or it is a linear, it can be cubic, anything. For example, 2x plus 3, right? Or I can take a quadratic one, 6x square minus 3x plus 2 kind of equation. Or there's a cubic one, 7x cube plus x square minus 6 x plus 2, right? Like this, right? Now, these are all polynomials. This is a degree 1 polynomial. This is a degree 2 polynomial. And this one is a degree 3 polynomial. Now, what is the difference between a polynomial and an equation? So how can I convert this polynomial into an equation? So if I equate it to something like 2x plus 3, and then I put an equal to sign here, right? Whether it is equal to 0 or it is equal to 6 or it is whatever. So whenever there is an equal to sign in between, understood? So it becomes an equation. So that's the basic difference between this is just an expression. This is a polynomial and this is an equation. Understood?
Yes, ma'am. Yeah.
Okay. Now there is another term. So for the first term, what is an equation? You know, right? So any polynomial which is equated to some number is an equation. Now what is linear? So linear, in case of polynomial, you know what is linear. It is actually a degree 1 polynomial. Understood? Okay.
Yes.
Now what is linear? We will see in a meanwhile. And there's another term which is called variable here. So variable is something which actually takes up different values. For example, this 2x plus 3. So what is the variable here? Basically x. So this is a polynomial in x. Or if I write 2x plus 3 is equal to 0, so this is an equation in x. So x is the one which can take up different values. X can be 0, 1, 2, whatever, like that. We can find out what is the value of x. So it is x which is changing. So x is the variable here, right? So x, y, or whatever you see in your equation, they are variables. Understood? Okay.
Yes.
Now, let me write what is called the general form of a linear equation. Yeah, and there is one thing. Now, so far you have learned about polynomials like this. There is only one variable. So this one has a variable x. Again, this one is a polynomial in x. Again, this one is a polynomial in x. But if I have something like this, or better, I should say equations now. So this is an equation in x, right? Now, if there is only one variable, understand? But if I have something like this, 2x plus 3y is equal to something like 8, okay? So now you can see there is one variable x plus there is another variable y. So this is an equation in two variables. Understand?
Yes.
Okay. So in this chapter, we will deal with equations which are having two variables, not one. Okay. Now, what is the general form? So these are the few things about linear equation. So I'm not talking about pair right now. Okay. I'm talking about a single equation for the time being. We will come to pair later on. So general form of a linear equation in two variables. Okay. So this is ax plus by plus c is equal to 0. So this is the general form. So it has two variables and a and b, c are coefficients, as you know, but where the coefficients which are a, b, c are real numbers. Understand? So real means they can be rational numbers. They can also be irrational number. I mean, they can be under root 2, under root 3 kind of numbers. And also they can be rational. So that means they can be fraction. They can be decimal numbers. They are negative numbers. Any kind of number they can be. And also there is one thing. And important thing, A and B are not both 0, right? So what does it mean? For example, if I have A also, like A is equal to 0, and if I have B also equal to 0, so my equation will become C is equal to 0, right, Tala? Yes. So, I mean, this is a false statement because any number cannot be equal to 0, right? This is false. Clear? Or if C is, let's say if C is also 0, then 0 is equal to 0 means nothing, like there is nothing. Okay, so the equation has gone. Okay, so simultaneously A and B cannot be 0. So we write this expression mathematically as, or A square plus B square cannot be equal to 0. So basically this expression is mathematically written like this. Okay, so this condition has to satisfy for a linear equation in two variables. Clear?
Yes.
Oh, okay. Now let us take one example of a linear equation in two variable. Very simple. From your book itself I'm taking. So 2x plus 3y is equal to 6. So this is a linear equation in two variables. Now first of all, let us try to learn how to plot an equation and then we will proceed further. So let us try to plot this very simple equation. Clear? Are you people also writing?
Yeah.
Okay. So please tell me if you are done. Like, have you written?
Yes.
Okay.
2 minutes.
Yes, sure.
Ma'am, why is it A square plus B square is not equal to 0?
Yeah, because let's say, yeah, wait, where's my pen? Yeah, let's say A is 1, right? And B is equal to -1. That can be an equation, isn't it? Like
Yes.
x and minus x, sorry, and then plus C is equal to 0 kind of equation. So in that case, if I do A plus B, so I'll get 0. Or no, ultimately, yeah, basically x will get cancelled out. Understand? And again, you will be left with C is equal to 0. Clear?
Yes, ma'am.
Yeah. So like this will not be an equation. This kind of equation will not be an equation. Ultimately, you will get C is equal to 0. And also if C is equal to 0, then 0 is equal to 0. So there's no equation. So that is why the condition is not A plus B is equal to 0, but it is A square plus B square is equal to 0. Clear?
Yes, ma'am.
Okay. Okay. So 2x plus 3y is equal to 6. Let us try to recall how to plot an equation. So we take different values of x. Let us take when x is equal to 0. Let's find out how much is y. Now from this equation, basically I'll get 3y is equal to 6 minus 2x, right? So my y will become 6 minus 2x divided by 3. Clear? So this is how I'll find my y. So when x is equal to 0, how much my y is? So 6 minus 2 into 0 and divided by 3. So this will become 6 minus 0 divided by 3. So this is 6 by 3, which is equal to 2, right? Okay, one value I can take x is another. If I take x is equal to 1, let's say, so my y will become 6 minus 2 into 1 and divided by 3. So this is 6 minus 2 divided by 3, which is 4 by 3. Although I can take this, but 4 by 3 will be difficult to plot on the graph paper, right? So I'll try to take that value of x for which I get y not as fraction. right?
Yes, ma'am.
Integer value I want to take. Okay. So let us try different value of x. If I take x is equal to 3, let's say, so y will become 6 minus 3 into 3 divided by 2. No, divided by 3, sorry. So this will be 6 minus 9 divided by 3. This will be minus 3 divided by 3. This will be minus 1, right? This is easier to plot on a graph paper. Clear?
Yes, ma'am.
Okay. So my table is basically this. Two values are enough to plot a line. Okay, so that's how you plotted x and y, right? So when x is 0, my y is coming out to be 2. When x is 3, my y is coming out to be minus 1. Clear? Let us try to plot it. Okay. So, yeah, sorry. Okay. Now this is my x. Yes, Tala, are you saying something?
Can you scroll up?
Sorry, please say a bit louder.
Can you scroll up?
Scroll down. You mean here? Okay. Yeah, please note down this much, then I'll proceed further. You make this table.
Ma'am, there is a
Yes. Yes, Tala, actually your voice is very not very loud. Please say a bit louder. Yes, please say.
there is a mistake.
Where? Yeah, please tell me.
Yeah. Here he wrote y equals 6 minus 3 in bracket 3 and in multiplied by 3 in bracket. Instead of 3, there should be 2. Right?
Oh, yeah. I'm really sorry for that. Yes, so did anybody else notice this was a 2 here, right? Oh, yeah, sorry. So I'm getting a wrong value. Please correct yourself, all of you. So, okay, thank you, Tala, for noting it. Okay, so basically this is 3 minus 2 into 3 is 6, right? And divided by 2. So this is 0 by 2 and I'll get my y is equal to 0. Yes. So it's not minus 1, I'll get 0. Clear?
The denominator is 3.
Oh, yeah. So anyway, 0 by 3 is 0. Clear? Okay. So let us come to the graph now. All right. So when my x is equal to 0, my y is 2, right? So I'm not writing numbers. You can see the grid on my screen. Clear? So this point is basically 0, x is 0 and y is 2, right? Okay. Now another point, when x is 3, y is 0. So that means you're 1, 2 and 3. So when x is 3 and y is 0, so this is the point, right? There's no y. So this point is x is 3 and y is 0. So these are the coordinates of the point. Now you have to join them. So that's how your graph looks like. So by looking at the graph, what we are observing that the solutions basically, see, these are the solutions, like the points which are getting that x is equal to 0 and y is equal to 2, right? And then other one, x is equal to 3, then y is equal to 0. So these are basically the solutions of these equations, right? So all the solutions of this equation will lie on the line. You can see that. So these are the points which are lying on the line. Clear? Like
Yes.
we are observing that the solutions are present on the line. This is our observation. Okay, so how many solutions are possible for this line?
Infinite.
Yes, anybody else? Tala, Sarah?
Ma'am, can you
10.
repeat the question?
Yeah, by looking at the graph, can you tell me how many solutions are possible for this equation?
Infinite.
Infinite. Why?
Because if we take a value of x, then we will get a unique value for y.
Exactly. So basically, yes, Sarah, you also see here, algebraically also, I have taken only two values, right? X is 0, X is 3, but I can take up infinite values of X, right? I can take up decimal values also, whatever, but I'm taking very simple values because I'm trying to plot it. The fractions, the decimals, they are actually difficult to plot on a graph paper. So I'm not taking it, but they are the possible solutions, isn't it? So I can take up infinite values of X and correspondingly I'll obtain infinite values of Y. And all those solutions, like all those combinations, they are going to fall on this line, right? So basically every point on the line is a solution. Understand?
Yes,
Yeah.
ma'am.
Yeah.
So yeah, so
Yes, ma'am.
basically, yeah, so all the like this is the note here or a remark. So all the points lying on the line will be solution of this linear equation. Understood? Or like converse, we can say that all solutions will lie on the line. Both ways we can say. All solutions will lie on the line. Okay, please write it down. Yes, written.
Yeah.
Okay, so
Yes, ma'am.
I skipped the term linear. So what does linear mean? So like linear means when I plot the graph, I'm getting a line, right? So if I'm plotting an equation like this, what was the equation? 2x plus 3y is equal to 6, right? This was the equation.
Yes, yes.
Yeah. So if I'm plotting a linear equation in two variable of this form, so the graph is actually a line. So that is from where the term linear is coming. Understand?
Yes.
So
Yeah.
linear means the graph is a line. So that is why we call it linear, or it is a degree one, right? Okay. So I think you understand a linear equation in two variables now, how to plot it, how does it look like, and what are the solutions of the line, where they fall basically on the graph. This much part is clear. Now we come to pair of linear equation, right? So far it was a single equation. Okay. So what happens when we have a pair? Now how to solve a pair, how to plot a pair of equations. So that we will do now. So next topic is pair of linear equations. Pair means two, that you all know. Pair of linear equations. Now, whenever there's a pair, now you have in mind how to plot it, right? So linear means obviously you're going to get a line in both the cases. Okay. Now on a graph, there can be three possible solutions. Either the lines are going to intersect, isn't it?
Yeah.
Yeah.
Yes, ma'am.
Either they can intersect, or there's another possibility that they are parallel, or what is the third possibility?
They coincide.
Yeah, they coincide, like one lie above the other. Clear? Like one line is this, another line also falls on this one only, same line. So these are the three possible possibilities. So just keep that in mind. Yeah. Talase.
Outcomes.
Yeah, I mean, these are the three outcomes. Yeah, definitely three possibilities. So now you know all the term, what is an equation, what is linear, what is pair. So I'm just writing what is the general form, because whatever formula, whatever results are there, we often write it in the general form. So we will write the equation in general form first of all. So how does it look like? It look like this, like a1x plus b1y and plus c1 is equal to 0, right? This is the first linear equation in two variable. Then the other is obviously a2x plus b2y plus c2 is equal to 0. And a1, b1, c1 are real number that you know. Similarly, a2, b2, c2 are also real number, and this follow the condition that a1 square plus b1 square is not equal to 0. Similarly, this one follows the condition that a2 square plus b2 square is not equal to 0, right? And a1 comma b1 comma c1 and a2, b2, c2 are real numbers. So this is the general form of linear equation in two variables. So you can see variable is same in both the equation, x, x, y, y, but the coefficients are changing. Yes, hello Abdullah, can you hear me? Yeah, Abdullah, please unmute your mic. At least type something if you are able to hear me. If there is
Yes,
some.
ma'am, I'm able to hear you.
Yeah, tell me one thing, you're almost half an hour late in the class. Why?
Ma'am, I was outside.
Yes, but how will you understand the chapter now? Because you have already missed the introduction and I've started a new chapter.
Ma'am, I have started this chapter in the school, so I already know half of it.
Okay, so at least the introduction part you know, right?
Yes, yes, ma'am.
Okay, anyway, I have not done much. I have just explained so far what is a linear equation in two variable, right? So what is an equation and why we call it linear? So we call it linear because the plot is a line, right? That is why it is linear. And now I have started what is a pair of linear equations. So I'm simply writing the general form. I have not done much so far. So, but please try to be on time in the class. Okay.
Okay, ma'am.
Okay, written all of you. Now let us look at the first example. We will try to understand with the help of examples. See, the concept should be very clear in your mind, then only you will be able to do the questions. So that is why I'm also taking up examples. Now, example 1, it's actually from your book only. So it says that represent given pair of linear equations graphically. Now, what are the equations? The first equation is x minus 2y is equal to 0. And the second is 3x plus 4y is equal to 20. So let us try to quickly plot them, right? So one side I'll solve for the first line and the second. Okay. So I'm taking the first one here. So x minus 2y is equal to 0, or I can call it my line 1, right? Line 1. So basically from here, I'll get what is the value of y from here? X is equal to 2y, right? So my y will become x by 2. Clear?
Yes, ma'am.
Okay. And from here, this is 3x plus 4y is equal to 20. So 4y will become 20 minus of 3x, and my y will become 20 minus 3x and divided by 4. Okay. So take up different values. For example, I say x is equal to 0. How much is y? Quickly find out. Y is 0 by 2, which is also 0, right? Now next take x is equal to 1. So I'll get y is equal to half. I am just trying to avoid fractions. Let's take x is equal to 2. So y will be 2 by 2, which is equal to 1, right?
1.
Okay, so I'm taking values which are easier to plot on the graph. Now similarly here, let us start with x is equal to 0. See, you can directly look here. When x is 0, this term is gone. This is 20 by 4, which is equal to
5.
5. Yeah, so take x is equal to 0. So your y will become 20 by 4, which is equal to 5. Next, if I take x is equal to uh, 3 into 5 is how much? 15, and 20 minus 15, no. If I take x is equal to 4, so 3 into 4 is 12. 20 minus 12 is 8, and 8 by 4 is 2, right? So do it in your mind. So take x is equal to 4. So y will become 20 minus 3 into 4 and divided by 4. So this will give you 20 minus 12 divided by 4. This is 8 divided by 4, and this is 2. So here my points are x and y. So when x is 0, y is 0. When x is 2, y is 1. And similarly here, when x is 0, y is 5. When x is 4, y is 2. Understood?
Yes, ma'am.
Okay.
Yes,
Let,
ma'am.
let us plot them on a graph. And yeah, for this chapter, you have to actually use a graph paper, right? So for the questions, I'll do it with a pen, but you have to use a graph paper for this exercise.
Ma'am, we can do it in a graph book, or should we stick to the graph paper?
Anything you can do as you feel convenient. You can do it in a graph copy also. Like in the examination, when the question will come, so you will require a separate graph paper to attempt this, right? And then obviously you're going to staple it with your answer sheet. Clear? Okay.
Yes, ma'am.
So quickly plot it for the first line. Okay, L1 I'm plotting. So when this is my x-axis, this one is my y-axis. So you please mark the number 1, 2, 3 that you already know. So when x is 0, y is 0, 1 point. So these are the coordinates 0, 0. Another x is 2, y is 1. So this is the point, right? 2 and 1. Okay. So quickly join them. Okay, sorry. Okay, I'm just roughly joining them, right? You can do it properly. So this will be the line. Mark it my line L1, okay? And similarly right here, this was your line L2. Please give it a name L2 so that, okay. So I'm plotting L2 now. When x is 0, this y is 5. So 1, 2, 3, 4, 5, right? This is the point. So this one is the point 0 and y is 5. Okay. Or I can use a different symbol. Okay. Now when x is 4, so 1, 2, 3, 4, y is 2. So when x is 4, y is 2. That's how you plot it, right? So basically this is the point. X is 4 and y is 2. So these are the 2 points. Now you join them. The different color I think I can use. So this is another line L2. Please use the scale and a graph paper. So this one will be your line L2. Understood? Yes. So in this case, what I'm obtaining, these are intersecting lines. Clear?
Yes.
Okay. So my L1 and L2 are intersecting lines. Okay. So like actually this is actually the point where they will intersect, because I have not done it, sorry, I have not plotted it properly with the help of a scale. So basically they intersect at this particular point, 4 and 2. Now what is the meaning of this point? As we have also seen in the case of polynomial, right, where the polynomial cuts the x-axis. So basically this means they are the zeros of the polynomial, isn't it? So what does it mean in the case of pair of linear equation? What is the significance of this intersecting point? That we will see later.
Solution of both.
Yeah, so there, this is actually a solution. Yes, good. So anyway, I'll come to the that part after plotting the other two examples. But okay, so far we have seen how to plot lines. How does intersecting lines look like? Let us come to another example. Example 2. Okay, you can just a minute. So this is actually the question. So this type of questions will also come in the exam, word problems, and you have to formulate the equation. So look at the question, represent the situation algebraically. So you have to form the equation, and then graphically also you have to plot them. What is the question? Now Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9, right? And her friend purchased something, 4 pencil and 6 eraser of ₹18. So we have to mathematically represent this situation first of all. So we don't know what is the price of pencil. We don't know what is the price of eraser. So let us assume, right? Let the price of pencil is rupees X, right? And let the price of eraser is rupees Y. Clear? Now, how to write it? So 2 pencils and 3 erasers combined, how much rupees? 9. So basically 2 into X. Clear? X is the price of 1 pencil and she has purchased 2 pencils. Right, Sarah? Plus.
Yes.
Okay. So Y is the price of 1 pencil, 1 eraser, and she has purchased 3 erasers. So total she has paid ₹9. So this is the first equation. Okay. Similarly for her friend, she has bought 4 pencils and plus 6 erasers, and then she has paid 18 rupees. So this is another equation, right? So algebraically we have represented the equations. Now let us try to plot them graphically. So if I assume again, same thing, I'm just doing it here only, you just scroll it. So if I assume this line 1 is 2x plus 3y is equal to 9, and my line 2 is 4x plus 6y is equal to 18. So I'm taking it line because already I know this is going to be a line, isn't it? That is why it is linear equation. So that is why I'm calling it a line. Okay. Now take values of x. So from here obtain y first of all. 3y is equal to 9 minus 2x. So your y will become 9 minus 2x and divided by 3. Similarly here, your 6y is equal to 18 minus 4x and y will become 18 minus 4x divided by 6, right? Okay.
Yes.
Now take values. Let's say if I take x is equal to 0, how much is y? Y is 9 by 3, right? Which is equal to 3. Good. Take another value, x is equal to
2. 3.
2. Yeah, so 2 is 4, 9 minus 4 is 5. So I'll get 5 by 3, which will be a fraction.
3.
Or
You can take 3 actually.
3.
Yes.
2 into 3 is 6. Yes, that we can take. So x is equal to 3 if I take. So y will become 9 minus 2 into 3 is 6 divided by 3, which is 3 by 3, which is equal to 1. Okay, so this. Now come here. First take x is 0, so it will be 18 by 6, right? So y will be 18 by 6, which is 3. Okay. What else I can take? X is equal to, if I take 4, 18 minus 4 is how much? No. 18 minus 4 is 4, so I'll get 4 by 3. No. If I take 3, right? 4 into 3 is 12, and 18 minus 12 is how much? 6. Yeah, I can take x is equal to 3. So y will become 18 minus 4 into 3 is 12 by 3, which is equal to, 6 by 3, which is equal to 2. So I think this is fine, right?
Yes.
Okay. So make a table to express it properly. So when my x is 0, my y is 3. When my x is 3, my y is 1. Okay, now for this one, when my x is 0, y is 3. When my x is 3, y is 2, right? Now, so have you written all of you so far?
Yes, ma'am.
Yeah.
Okay, let us try to plot it. All right. So this is my x-axis, this is my y-axis. Let us start. When x is 0, y is 3. So this point, this is your 0 and 3, clear? When x is 3, that means 1, 2, 3. When x is 3, y is 1, this point. So this is your 3 and 1. Okay. So one line. I mean, use your scale. I'm just drawing it like this. Okay. Now next. When x is 0, y is 3. Same point I'm getting. Yes.
Yeah. Yes, ma'am.
And when my x is 3, y is 2. Is there a mistake? No, I've done a mistake somewhere. One point is coming common. It should not come common actually. Yes, Tala, can you spot the mistake I've done?
Yeah, ma'am, here in
Hmm.
down y equal 18 minus 12 by 3, you wrote 3 in the denominator 56.
Oh, yes. Oh, yeah. That is why I'm getting a
A coincidence.
Yes, am I audible?
Yes, ma'am.
Okay,
Yeah.
sorry, I lost my connection. Okay. Yeah, so for the second line, L2, okay, this was my line L1. Now for the second line, first point is 0 and 3. So when x is 0, y is 3, like same point, right?
Yes.
And the second is when x is 3, y is 1. So again, the same point. So my one line is falling above the other. This is also my line L2. So basically, these are coinciding. Yes, Sarah? Shri Harsha?
Yes. Yeah.
Okay. Now, why I'm getting a coinciding lines? In the first case, I was getting intersecting lines, and here I'm getting coinciding lines. So if I again look at my equations in this case, see, these were my two equations, clear? Now,
Mom, if we simplify that as an equation.
yeah, so if I look at my second equation, 4x plus 6y is equal to 18, right? And if I take 2 common from it, so I'll get 2x plus 3y, and again here 2 into 9, right? I can write it like this. So basically this 2 will get cancelled out, or if I divide throughout by 2. So this 2 will be gone and I'll obtain the same equation as 1. Understand? So basically
Yes.
here in this case, my one equation can be derived from the first one, isn't it? So these type of equation where one equation can be derived from the other. So basically they are equivalent equations. Understand, Abdullah?
Yes, ma'am.
Yes. So that is why, like, if your equations are equivalent, in that case, the result is going to be coinciding lines. Clear?
Yes, ma'am.
Okay. So basically it is the same equation. So obviously its solutions will, they all fall on the line itself. So one line will be above the other, and all the points, like every point is common in that case. Okay. Again, let us look at the third example also before starting the exercise. Let me just insert the example. Okay, so directly two equations are given here. One equation is x plus 2y minus 4 is equal to 0. And the other equation is 2x plus 4y minus 12 is equal to 0. Okay. So obtain your y from here. So 2y will be, I'm taking everything on the other side. So 4 minus x, and your y will be 4 minus x divided by 2. Okay. Here 4y will be 12 minus 2x, and then y will be 12 minus 2x and divided by 4, right? To make it simple, I can take 2 common thoroughly. This will be 6 minus x divided by 2 to make my calculation easy. Okay, now take values. So if x is 0, so y will become 4 by 2, right? Which will be 2. Again, if I take x is equal to how much?
2x.
Uh, 2, 4 minus 2, yeah, I can take 2. So my y will come out to be 4 minus 2 is 2, 2 by 2 is 1. That calculation you can do. Now here, if I take x is 0, so y will come out to be 6 minus 0. 6 by 2, 3. When I take x is equal to, I think again 2 I can take, right?
Yes, ma'am.
So y will be 6 minus 2 is 4. 4 by 2 is 2. So points I've got. Let us try to plot them. So you can write it properly, x and y. So when x is 0, y is 2. When x is 2, y is 1. Here, although it's written, but x is 0, y is 3, x is 2, y is also 2. Use a graph paper now. So are you able to see the grid on my screen, all of you?
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Okay. Fine. Oh, yeah. Okay, now start. So when x is 0, this is x and this is y. So when x is 0, y is 2 for line L1. X is 0, y is 2. So this point. When x is 2, y is 1. So this point, right? So this is one equation, one line I'm getting. So this is the graph of L1. Now come to L2, this one. When x is 0, y is 3. So this is the point. When x is 2, y is also 2. This is the point, right?
Yes.
So this is another line I'm getting. So in this case, what I'm getting? Parallel lines.
They will not have any.
Yes. So will they intersect anywhere? No, parallel lines do not intersect anywhere. So that means there is no common point between the line. That means there is no solution possible. Clear?
Yes.
All right. So lines are basically parallel. So we have seen the lines are parallel. Let us come to the exercise. We have time. Let us try to finish the first exercise. So far we have basically revised how to plot lines, right? We have got an idea in which case we are going to get intersecting lines, in which case we are going to get coinciding lines, and oh yeah, parallel lines also. So we will talk about solutions in the next exercise. So far this was graphical representation. That's it. And now come to exercise. Yeah, first question. Now, Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Okay. So, and 3 years from now, right? So, basically, there are two people here. One is Aftab and one is daughter. We don't know their ages. So, first of all, we will assume. And we always assume the present age mostly. So, let us assume. Or write like this. Let the present age of Aftab is X, right? X years, obviously. And similarly, let the present age of daughter is how much? Y years. So we have assumed the present age. Please note, this is the present age. Now come to the question. What is it saying? Now, 7 years ago, that means, okay, 7 years ago, what happened, right? 7 years ago. 7 years ago, there is a condition. I was, that means, okay, 7 years ago, what was the age of Aftab?
X minus 7.
Yes, so present age is X years and 7 years ago, X minus 7, right? And what is the age of daughter 7 years ago? Sorry, daughter.
Y minus
Y minus 7. Okay. Now come to the condition. So what is it saying? That I was, that means your X minus 7 was, basically Aftab was. Okay. So was meant put an equal to sign. I was 7 times as old as you were then. So that means daughter was actually Y by 7. And the 7 times of this daughter's age was the age of Aftab. Understood?
Yes.
Yeah, so this is the mathematical representation of the statement which is given to you. Understand, Sarah? Shri Harsha?
Yeah.
Okay, so just simplify this. So x minus 7 is equal to 7y, and then 7 minus 7 into 7 is 49. Then x minus 7y is equal to minus of 49 and plus 7. So this will give me how much? X minus 7y is equal to minus 42. So this is the first equation. I mean, I have converted it into the general form, or you can use it like plus 42 is equal to 0. That is also fine. You can write it like this also, right? Okay. Now come to the second condition here. Now, what is the second one? 3 years from now. That means after 3 years, he's talking. So first of all, let us write down the ages after 3 years. After 3 years, what will be the age of Aftab?
X plus 3.
Yes, x plus 3. So present is x plus 3 years. Okay. And age of daughter? Present age is y and plus 3, right? So after 3 years, she will be y plus 3 years. Yes. Now come to the state condition which is given. I shall be, okay, I shall be, that means Aftab will be. So basically your x plus 3 will be how much? As 3 times as old as you will be. So 3 times of the daughter's age, which is y plus 3. This is the equation. Clear?
Yes, ma'am.
Right? So I'm just writing it here. Oh, sorry. Yes, so this is the equation that x plus 3 will be equal to 3 times of the daughter's age after 3 years. So just simplify, x plus 3 is equal to 3y and 3 plus 3 is 9. So x minus 3y, and this 3 minus 9 will be minus of 6, right? Is equal to 0. Like same way you will write this equation also. This is your equation number 2. So these are the two equations I have got. So algebraically I have represented. Now graphically also I have to represent this situation. Right?
Yeah.
Let us try it graphically. So again, come to the first equation now. This is the equation. What was the equation? X minus of 7y and plus 42 is equal to 0, right? So this will give me x minus 42 is equal to 7y, and then your y will be x minus 42 divided by 7, right? Now you take up different values of x. So when x is equal to 0, how much is y? Quickly tell me. Y will be minus of 42 divided by
6.
7. No, not 6, minus of 6. Yeah. Or, oh, yeah. One mistake. X minus 42 is equal to 7y. Y is equal to x minus 42. It is 6 or minus 6?
Ma'am, if you check the first equation, it is 6 only because it's already minus 7.
Oh, wait, have I done any mistake here? So x, sorry, it was x plus 42 is equal to 7y, right? Oh, yes. Yeah, there was a mistake I've done. So it will be 6. Okay, fine. Now take another value. X is equal to, see, I want to obtain a 7 in the denominator because I have a 7 in that, sorry, I have 7 in the denominator. If I want to get 7 in the numerator, which value I can give x? Or it should be a multiple of 7 like, at least. If I take x is equal to 6, let's try if x is 6, so 6, no, if x is 7, let us try for x is equal to 7, right? So this will be 7 plus 42 divided by 7. This will be 49 divided by 7, which will give me 7, right?
Yeah.
So can I take x is equal to 7, right? So my y will become 42 plus 7. That means 49 by 7. This will give me 7. Clear, Tala?
Yes, ma'am.
Yes.
Okay, so the first one, basically I've got x and y. So when my x is 0, y is 6, x is 7, so y is also 7. So any value you can take. Now come to the second equation. Please tell me what was the equation. I think x minus of 3y minus 6 is equal to 0, right?
Yes, ma'am.
Okay, so from here, my y will become x minus 6 is equal to 3y, right? So y it will be x minus 6 divided by 3. Now try to give different values of x here. So when x is 0, first y will become minus 6 divided by 3. This will give me minus of 3.
-2.
Oh, sorry, minus of 2. And if x is how much? If x is 6, can I take? So y will be 6 minus 6. That is 0 by 3. It will give me y is equal to 0. Fine.
Yes, ma'am.
Okay, I think it's fine. So just give an idea to the range. My x is going to 7. Okay, so like that, take space on your graph paper. Let us try to plot it. How does they look like? Yeah, so my first table is this. X is 0, y is 6, x is 7, y is also 7. And my second table is when x is 0, y is minus 2. When x is 6, y is 0. Let's use a graph here. So just have an idea. See, y is going from, yeah, y is taking up 6 values also. So I think y is not taking much of negative values. So I can draw my line here. Right, it's going only up to minus 2. So that I can plot easily on the graph paper.
We can take the
Now,
scale as 2.
I think it's not necessary because 6 up to 7 you can easily plot on a graph paper. There's no issue.
Okay, ma'am.
Yeah, take one block is equal to 1. So 7, 6, 7 can easily be plotted. It's not such a big number. Let us start. So when my x is 0, y is 6. So when my x is 0, y is 6. So this is a 1, 2, 3, 4, 5, and 6. So this is the point, right? You can extend your graph here. So this is the point. So mark this point. This is 0 and 6. Okay. Next, when my x is 7, y is also 7. So I'll need some more space. Let me just use my eraser. So I can extend this line. Yep. Now next point, x is 7, y is also 7. So this is 1, 2, 3, 4, 5, 6, and 7. So x is 7, y is also 7 here, right? This is 7, 7. Understood, all of you? Any confusion?
No, ma'am.
No.
Okay. You can also like draw dotted lines here if you find it difficult to plot. That's how you do in the coordinate geometry, right? Okay. So join them. Yeah, the first line we have got. I'm just roughly drawing it. I think somewhere it will look like this. Fine. Now look at the second one. So please tell me the table again. What were the values? When x is 0, how much is y?
-2.
Okay, and
When x is 6, y is 0.
y is 0. Okay. So when x is 0, y is minus 2. So this is minus 1, this is minus 2. So this is the point, right? So mark it. This is 0 and minus 2. X coordinate 0, y coordinate minus 2. Second point, when x is positive 6, y is 0. So this is the point, right? Okay. So this point is 6 and 0. Clear? So join them. Oh, I think after a long distance they are going to meet, right? Okay, so it will be difficult, I think. But I think it will be possible on your graph paper if you draw this x's on the extreme left side, because see, you are not getting any negative value for x, right? See, you have a graph paper like this, clear? So it's not always necessary that you draw the x's in the middle of the graph paper, clear?
Yes, ma'am.
Yeah, just go through the numbers. Here you don't have any negative value of x. You have x0 and x7. You have x is equal to 0, x is equal to 6. So in your graph paper, you can just plot the x's here, right?
Yes, ma'am.
So
Ma'am,
you
I
can
have
start.
already drawn, so can I just change the scale?
Yes, you can change. Yeah, fine. That's okay. No problem. Like scale, you can change anytime. I was just trying to take the same scale as your graph paper, but I think the lines are going to meet after a long distance. So in that case, you can change. Let us try to plot it again. Yeah, and Sarah, have you understood the problem I'm facing here? Tala,
Yeah.
Abdullah? Yes?
Yes, yes.
Yeah, although the graph is correct, but you will not be able to show where the lines are meeting. So what will I do? I'll change the scale of the graph. How? Let me draw it again. Okay, roughly I'm drawing quickly. Oh, time is also over. Yeah. Please quickly tell me the values for the first line. X is 0, Y is?
6,
Then
7, and 7.
7 and 7. Second one?
X is 0, Y is minus 2.
Hmm.
X is 6, Y is 0.
Okay. So if I take my 1 unit is equal to 2 years, right? Yes. Sarah, this
Yeah.
is the unit. My 1 unit is equal to 2 years. So that means instead of marking 1 and 2, I'll mark the first unit is 2, right? Second unit is again 2. So this will be 4. This will 6. This will be 8, like this. Understood?
Yeah.
Right, Sarah? Abdullah, Tala, any problem?
No, no.
Yeah, so please write this. This is important. Mention your scale which you are using. 1 unit is equal to 2 years. Similarly for Y, so this will not be 1, but this will be 2 now. So 2, 4, 6, and 8, like this. So this is 10. This is also 10. Now let us try to plot it. So when X is 0, Y is 6. So X 0 means this is obviously the 0 point. Y is 6. So the first point, right? Now when X is 7, so see, this is 6 and this is 8. So the middle point will be 7, clear?
Yeah.
And similarly here, the middle point will be 7. So when X is 7, Y is 7. So you will have to look at this middle point. You will drop perpendiculars from here. You will drop here. On your graph paper, it will be easily visible. So this is the middle point. So this is the first line I have drawn. Something like this, right? My line L1. Similarly, if I plot my line X2, so when my X is 0, Y is minus 2. So again, this will be your minus 2, right? So this is the point. Yeah, please mark the coordinates also. I've just forgot to write. So this one, it was 7, 7. And this one was 0 and 6, right? And this coordinate is 0 and minus 2. Okay. Next, when X is 6, Y is 0. So that means this point. So this is my coordinates 6 and 0. Clear? Now join them. So now somewhere you will be able to see that the lines will intersect like this. Clear? And
Yeah.
use graph paper, please. So all of you will plot the question on the graph and you will send me a picture of your graph, all of you, on my WhatsApp. So do you have my number, all of you? Abdullah?
Yes, ma'am.
Yes.
Talha? Okay, so you will finish this question and send me the picture of the graph you have plotted. Next 2 questions, next class. Okay, then.
Only this one, right?
This one we have to.
Yeah, okay, this one, please at least show me the first one. Yes, properly. Okay, then I'm ending the class today. We will again meet on Tuesday now.
Thank you, ma'am.
Okay, thank you.
Something.